All right, in the previous lesson, we talked about how to set up elimination. So today is more about just explicitly going over the method of elimination. We've already gone over systems graphically and with substitution. So remember from the last lesson that the properties of equality are used to rewrite either of the equations, and the equations are added or subtracted, or any rewrite is added or subtracted. So you're constantly making the two equations into a giant addition problem. So let's consider the system shown below. So both of these systems are the same, but we want to solve it in two different ways to show that we can eliminate x in the first one and we can also eliminate y in the second one without doing any substitution at all. So if I want to eliminate x in the first one, that means that I am going to want to make these two numbers the same. So if I want to make both of those numbers the same, I'm going to need to multiply the bottom equation by something in order to get to the same, because you want the same number but opposite. So 4, I want to make the bottom one -4. So that means I have to multiply the bottom one by 2. So it becomes -4x plus 2y equals 16. Because remember, anytime that you multiply 1 in that equation, you have to multiply all 3. Then we're just going to transfer over the 4x plus 5y equals 12. Now we have our giant addition problem. So the x's eliminate, 7y equals 28, divide by 7, and y equals 4. So we eliminated x in the first one to find y. We could do the same thing to eliminate y, but this time I want to get the y's to both be 5. So the bottom one is 1, so we multiply by 5. But if the top equation is a positive 5, the bottom equation has to be a -5. So if I multiply all 3 of those, I get positive 10x -5y equals -40. Again, we're just going to transfer over the top equation. So positive 4x plus 5y equals 12. And again, we have a giant addition problem. The y's eliminate. 14x equals -28. Divide by 14, and x equals -2. So the point that we found in A for y was positive 4, and the point that we found in B was x, which was -2. So the solution to that equation is -2, 4. So this one, we can again solve by elimination. But you can't just multiply one of them, because for the x's, they're 5 and 2. I can't multiply by 2 by anything to get to 5. And for the y's, it's -2 and 7. I can't multiply the 2 by anything to get to 7. So we're going to multiply both equations by something. I personally am going to choose to get rid of the y's because I already have a negative y and a positive y, so that way I'm not multiplying by a negative number. So in order to do that, I want to multiply the top equation by 7 and the bottom equation by 2, so that both of the y's become 14. So the top equation becomes, well, 7 times 5x is 35x. -2 times 7 is -14y equals, and 7 times 10 is 70. The bottom equation, 2 times 2 is 4x. We have positive 14y, and 2 times 43 is 86. Now we have our giant addition problem where the y's eliminate. So 39x equals 156. We divide by 39 on each side, and 156 divided by 39 is 4. So we could do exactly what we did on the previous question and do elimination to get rid of the x's, or we can just substitute it back in using what we know about substitution. So I'm going to use the bottom equation, and we're going to use the original equation. So instead of 2x, it's 2 times 4, because we just found that x equaled 4, plus 7y equals 43. You really could use the top equation too. I just chose the bottom equation just because. So 8 plus 7y equals 43. Subtract 8 from each side. 7y equals 35. Divide by 7, and y equals 5. So our coordinate point, x is 4, y is 5. It told you to check that your answer is a solution to the system. I'm not going to go through and do that, but I'm hoping you understand how to do that, since in all of our previous lessons we've done that multiple times. That means you would plug 4 in for x and 5 in for y and show that both of those equations are true. There are many applications of solving systems of linear equations by elimination. One of the more interesting ones comes in finding the equation of a line if you know 2 points that it goes through. So consider a line that passes through the points -2, -11, and 3, 14. We want to find its equation in y equals mx plus b. So we're going to substitute both of the known points into y equals mx plus b to create a system of 2 equations with the parameter m and b. So if y equals mx plus b, our first equation, our y is -11. We don't know the m. We know that the x is -2, and we don't know the b. The second equation, the y is 14. We don't know the m. We know the x is 3, and we don't know the b. So we wrote 2 equations with the parameter m and b. So now we're going to take both these equations, and we are going to solve for m and b and write the equation of the line. So if I have -11 equals -2m plus b, and 14 equals 3m plus b, we can solve by getting rid of the b's, by eliminating the b's. So in order to do that, we're going to need to multiply one of the equations by -1. I'm choosing the top equation because then I have all positive numbers I'm dealing with. So let's put that equation here. It becomes +11 equals +2m and a -b. So now we have these 2 equations where the b's eliminate, and I have 25 equals 5m, divide by 5, and our m equals 5. I know I'm running out of room up here, so we're going to try to do our best. So I can plug m in to find our b. So pick one of the equations. I'm going to use this equation. So 14 equals 5 times 3 plus b. 14 equals 15 plus b. Subtract 15, and b equals -1. So our equation becomes y equals 5x minus 1, because we found that our m was 5 and our b was -1. So now we're going to find the equation of a linear equation in y equals mx plus b shown in the table below. We can do exactly what we just did by just picking 2 points. So let's say that I pick this point of -2, 3, and I pick this point of +2, 5. And we're again going to do exactly what we did up above. So our first equation, 3 equals m times -2 plus b, and 5 equals m times +2 plus b. We're going to rewrite them. 3 equals -2m plus b, 5 equals 2m plus b. By rewriting them, it's a little bit easier to see that we can already eliminate the m's. So 3 plus 5 is 8. Oops, might help if I have the right writing utensil. 3 plus 5 is 8. The m's are gone, and I have 2b. Divide by 2, and our b equals 4. So in our equation, we still haven't found our slope, but we know that the y-intercept is 4. To find our slope, we're going to plug 4 back into one of the equations to find m. I'm going to use this equation. So 5 equals 2m plus 4. We're going to subtract 4 from each side. 1 equals 2m. Divide by 2, and m equals 1/2. Remember, when we're talking about slope, it's okay to have a fraction. So our equation, y equals 1/2 x plus 4. So we're going to work extensively in the next lesson with modeling real-world scenarios, but here's a warm-up to get us kind of prepared for the next lesson. Two numbers have the following properties. The sum of the larger number and twice the smaller number is equal to 13. Twice their positive difference is equal to 8. What are the two numbers? So we're going to play around with modeling this problem using variables. We're going to create careful let statements and equations that translate the information we're given into a system we can solve. So let statements is when you're saying let x stand for our smaller number and let y stand for our larger number. So now we just have variables that are going to be used the same way. So the sum of the larger number, which means y plus, and twice the smaller number, remember the word is means equals, to 13. We have one equation. Our second equation, twice their positive difference. So twice the positive difference, which means in order to get a positive difference, you have to take the larger number minus the smaller number, is equal to 8. So now we need to do distributive property with the second equation to kind of see what we're dealing with. So this equation becomes 2y minus 2x equals, still 8. I was wrong. I don't know why I said that it needed to be multiplied by the 8 also, because the 2 only applies to the y and the x. So 2y minus 2x equals 8. We're going to rewrite those. I have 2x plus y equals 13. Negative 2x plus 2y equals 8. I just rewrote it so the x's come first in both equations. Now we have our giant addition problem, and you see the x's eliminate. So 3y equals 21. Divide both sides by 3, and y equals 7. So finding that first one's pretty easy. Now we're going to substitute. I'm going to use this top equation to substitute because it looks easier. There's no negatives. So we're plugging 7 in for y. We still don't know x, but it equals 13. Subtract 7 from each side. 2x equals 6. Divide by 2, and x equals 3. So we have an x and a y, but we're talking about a word problem. So our smaller number is 3, and our larger number is 7.